Hello. I would like to demonstrate the operation of a digital multimeter measuring voltage, resistance, and current. My name is Ralph Webb, and this is a digital project for the Provincial Instructors Diploma Program at Vancouver City College. I'd like to demonstrate now using a Fluke multimeter. This Fluke digital multimeter is a general purpose meter. It is fairly sophisticated. It does have some advantages over some of the other meters, but it is a fairly basic meter as far as digital multimeters go. Most meters will have the functions that we are looking at for measuring these basic functions for this DC supply. Okay, I'd like to first of all start with the measurement of resistance. Resistance is measured quite simply by using this meter, making sure that the red lead is connected to the volts and ohms of the meter, and the black lead is connected to the common lead of the meter. First of all, you select over to ohms, omega, here, and the meter will automatically turn on, and the resistance measurement, a loose resistor, is measured quite easily by putting the black lead on one side of the component and the red lead on the other side of the component to measure the resistance of, in this case, 0.988 megohms. The nominal value of this particular resistor is 1 megohm. It's very important to remember not to hold both sides of the component, the loose component, because it's very easy to measure the resistance across your body if you do that. For instance, if I held both sides by my hands here, it would change to 0.5 of a megohm, whereas the actual resistance reading is 0.9 of a megohm. It doesn't make much difference for smaller values of resistance. I've got a smaller value of resistor here, 3.83 kilo ohms, and if I hold both sides of this one, you read very much the same number. In fact, this is the same number. So the higher value of loose resistor, you would use the more effect of holding both sides of the component. To measure a resistance in a circuit, I have diagrammed a simple circuit here, a series parallel circuit of 1,000 ohm resistors in series parallel. It's important, of course, to measure resistance when the circuit is unpowered, not connected to a power supply. So very simply, put the black lead on one side of the circuit and the red lead on the other side of the circuit to read any particular resistance across the complete circuit. If you wanted to measure a particular value of any one of the resistors in the circuit, by putting the leads across the component like this would give an erroneous measurement because the circuit is complete. It's important to isolate the component by pulling one side up and measuring the component across this way to read 987 ohms. This nominal value is 1,000 ohms, 9.87 ohms. Isolate the component before you take a resistance measurement of a resistor in a circuit. Any particular value can be looked at. And the circuit returned to normal. That completes the resistance measurement of the procedure. I'd like to discuss looking at measurement of voltage. First of all, we have a power supply which will connect to the circuit. The red lead goes on one side of the circuit, and the black lead goes on the other side of the circuit. And moving the meter now to voltage, DC voltage. The black lead is connected to the negative or the black side of the meter or the circuit, and the red lead is connected to the other side, the red side of to measure the volts, 20.62. Any particular voltage can be measured within the circuit by strictly putting the leads anywhere in the circuit to measure a particular point in that circuit. Voltage may be read across a component, an individual voltage drop, by putting the black lead towards the black negative of the power supply and the red towards the red positive of the power supply, and a voltage can be read across a component. In this case, 5.12 volts. And as these resistors are all the same value, we should be reading a very similar voltage across the components. And so on. That completes the measurement of resistance and voltage in a simple DC circuit. I would like to explain how to measure current. I'm going to use another meter here using clip leads. They're easier to work with and hold on to the component much easier. Measuring current is very much the same as resistance in a similar way, that the meter must become part of the circuit. So instead of hooking my positive and negative of my power supply directly up to the circuit in question, I have to break the circuit and I have to insert my meter. But first of all, I have to take my red lead out of the volts and ohms and place it in the highest current, 10 amps in this case, of my meter. I then take the red lead, my positive lead of the meter, and put it on the red positive lead of the power supply. Move the meter over to measure current. Connect the black lead or the remaining lead of the meter onto the power supply and turn the power supply on, and I'll measure 0.01 of an amp. I realize that is lower than my lower range to get a far more accurate reading of 300 milliamps. Turn my meter off. Connect the red lead to the 300 milliamps. Turn the power supply back on, and now I read 10.40 milliamps in the circuit. The meter now is in the circuit. It forms part of that circuit. I can look at the particular current anywhere inside this circuit by breaking the circuit at the point I wish to measure. I would put the power supply back into the front and back. I would then insert my meter anywhere I would like to measure the current. The red lead towards the red hot of the power supply, the black lead towards the negative of the power supply. Turn my power supply back on and read 4.15 milliamps. 4.15 milliamps through this part of the circuit, whereas I had a total of 10 point something milliamps as a total current. To return the circuit to normal, power supply off, remove the meter, and back on the proto board, and I could measure any particular point that I wished for current measurements. So that completes the measurement of current, voltage, and resistance in a simple DC circuit. Thank you for watching.